So, hello, good afternoon, everyone. My name is Tan Song. I am a postdoc at George Mason University. So, I'm excited to present our work VLTGS, and this work was co-authored by Jing from UMD. So, yeah, as robots enter our everyday life, everyday spaces, it's no longer just enough to avoid collisions. Robots need to understand the context, like it has to stay on the sidewalks or it has to cross the crosswalk on the designated crossings. So geometric sensing alone isn't enough. So we ask, um, can we leverage vision language models to make more human-like decisions? So we present VLTGS, and this is a short demo of VLTGS navigating through our outdoor scenarios like crosswalk that has crosswalks in around the corner scenarios, flower beds, and curves. So those scenarios that require more than just geometric information. VLTGS has two stages. First, generating the candidate trajectories with conditional variational autoencoder using lidar and velocity. And we mark those candidate trajectories onto the robot view image. And second, using the VLM, we select the best one by analyzing the image and understanding the context with a given prompt. So this fusion enables our method to generate both geometrically and semantically feasible decisions. In the first stage, our CVAE generates diverse trajectories within the 10 meters ahead using LiDAR and robot motion. It ensures that the candidates are safe and cover possible traversable areas without needing a map information. So something like this. So in the second stage, we leverage a VLM to select the most contextually appropriate trajectory. We overlay the generated path onto the camera image and label them with numbers. Then we prompt the VLM using natural languages so that we can pick the most human-like and semantically valid path. So this is a real deployment using VLTGS on a ClearPath Husky. So to be clear, all the methods, all the models are doing mapless navigation. The goal and the current position of the robot is given by GPS. Except that Nomad, which is doing a vision-based navigation, which relies on a topological graph, which is built by pre-navigating the same path. Yeah, I'll cut the video just for the sake of the time. So yeah, compared to other existing methods, VLTGS outperforms in choosing both geometrically and semantically valid paths. And quantitatively, VLTGS outperformed a prior method in both traversability and human-like distance measures, which is a fresher distance. We also performed ablation study on both trajectory generator and the selector. So without our CVAE-based trajectory generator, just by randomly generating candidates, which is same as what Pivot does, or linearly connecting a set of points, which is same as what Convoy does, often like visible or safe trajectories. So giving a good geometrically feasible candidate trajectory is important. So, and without VLM-based trajectory selector, what MTG does is it generates multiple geometrically feasible candidate trajectories and then select the shortest path to the goal. So if the goal is somewhere behind the building, it may try to cut through the building. So VLM brings a human-like reasoning into the loop, selecting the semantically feasible path, like the path that is on the pedestrian walkway or on the zebra crossings and goes around that corner. So yeah, to wrap up, we propose two-stage trajectory generation and selection method by generating multiple geometrically feasible candidate trajectory and using a generated model, and then by selecting the semantically feasible candidate trajectory using VLM with visual prompting method. Yeah, so thank you. Yeah, you can, the QR code will lead you to the project website.
I think we have time for two questions. I had a question.
That's well done. Yeah, please go ahead.
Um, Hi, I just wanted to know, did you find any, what were your observations of the diversity of the trajectories in the presence of humans?
Oh, sorry. I'm not sure if I got your question correctly. So was it about the human velocity?
No, I'm
Diversity. Sorry, can you
the
repeat the
diversity
question
of
once
the,
more?
I can repeat. So my question is, what were your observations on the diversity of your trajectory, of the trajectories generated by your generator? Um, when human on the robot, did you see any interesting behaviors?
Okay, yeah. So diversity, in terms of CVAE-based trajectory generator that we worked on, um, in terms. So I'm not sure if I got the question correctly, but we are trying to generate a diverse trajectory that are within the traversable areas, and that could be controlled by the loss term in our training model. And I think you also mentioned the humans.
I think if you rephrase the question in a way that's more digestible, it would probably be how does your model behave around humans? Because what did you
Okay,
observe?
right. So yeah, that's a good question, I guess. So actually, when we train the CVAE-based trajectory generator model, our data set doesn't contain any human in front. However, because the trajectory generator does consider the lidar as an input, it can consider the human as an obstacle and avoid somehow, but it's not guaranteed. However, because VLM has a capability to like understand the image on the scene. This could be a good example. I think it can if we do have a trajectory generated that does avoid the human on the scene. VLM can select the path that does avoid the human. So yeah, so I hope that could answer your question.
Thank you.
Okay, we have one more question here.
What is the limitation of your system?
Yeah, that's also a good question. I would say because right now we are depending on the large VLM to select a good path. That could be both our limitation and a point that could improve our work because as VLMs are improving like daily. Also, the response time of the VLM was an issue. However, we could mitigate that issue by generating a path, like long range path, something like right now we are generating 10 meters ahead. So that gives us some, like earns us some time to get the response back from the VLM. However, if you want to like more frequently like prompt the VLM, that could be some like issue.
Okay, thank you.